Okay. Okay, now we graduated. We have done all this. We have last portion, only one last section to this. Okay, so we have graduated from all these. We have. Okay, so now the third thing we learned was this. The final thing we're going to learn now is deduce y equals to f prime x. Now we're going to do this. What is f prime x? F prime x is the gradient function. Gradient function. Okay? Gradient function. This is what we're going to do. Okay, before we start on this, there are some preliminaries, a bit boring but essential. Okay. If your y is defined such that your dy dx over an interval, that means over from x goes to a to x goes to b, dy dx is positive. It means that y increases as x increases. But there are two ways to increase. There are really two ways. You can increase it like that, or you can increase like that. Do you see a difference? Yes, there is a difference. Later I'll explain what's the difference. Ken? Is your friend okay? Wake her up. Okay? Okay, have the moral courage to wake your friend up, okay? Otherwise your friend will scold you. Why didn't you wake me up? Okay? Come. What if dy dx is negative? Decrease, you can decrease it two ways. You can decrease it like that, or you can decrease like that. Whoa, whoa, whoa. Yeah, sorry, yeah. Okay. Now, let's focus on what is d2y dx squared. We have learned what is this, but many of us didn't really realize what actually does it mean. This is actually d over dx, dy dx, am I right? If dy dx is the rate of change of y, d2y dx squared is the rate of change of dy dx. Correct? I say one more time, I say one more time. If dy dx is the rate of change of y, d2y dx squared is the rate of change of dy dx. That means how fast the gradient is changing. So if I tell you d2y dx squared is positive, it just tells us that dy dx increases as x increases. Correct? Okay, then you tell me, out of these four, number 1, number 2, number 3, number 4, which one or ones correspond to this d2y dx squared positive? Which one or ones? Number what? Number 2. Number 2. Many of you say number 2. Number 2, gradient increases as x increases. Correct? Yes. You put a ruler there, you know. Any others? 3. 3 as well. Obvious? You put a ruler there, the gradient increases as x increases. Correct? It becomes less negative. So it's increasing. Correct? Maybe at this point, the gradient is negative 2. Then at this point, the gradient is negative 1. So it also increases. So there are two, it's either this or this. Correct? Now, then is it obvious to all of us? Then these two looks What can we say about this? The curve concave upwards. When we say concave upwards, some of us may think, hey, what is it? It's easy to remember. When you say concave upwards, it just means that it forms part of a smiley face. Right? It forms part of a smiley face. As long as it forms part of a smiley face, it means concave upwards. Which you piece up your knowledge, your O-level knowledge of second derivative test when you want to find out whether it's minimum or maximum. When you want to know whether it's minimum, your d2y dx squared must be positive. So which is why, of course, because at this point, if it's like that, then it's a minimum. So the curvature helps to test whether it's a minimum point or maximum point. Does it make sense now? That's now you know why lah. Previously you don't know why. I just test lah. Negative just means more positive just means minimum point. You follow what I'm saying? So similarly, if your gradient is decreasing, then you have one of two shapes. Either it's like that, or it's like that. And again, this means concave downwards. How to remember concave downwards means set face. Okay? Concave upwards means smiley face, part of a smiley face, part of a set face. And now you know why second derivative test works, because once you have d2y dx squared negative, it means it's set face, therefore you have a maximum one. Make sense? Okay, there's a reason why I do all this, okay? Okay, all these are there, okay? Can. Okay, let's do this. Very stupid, right? Put something. Okay, next time I adjust the level such that I can see, you cannot see. Okay. Now let's try and sketch the graph of fx given that the gradient is always positive for all x. Okay, gradient always positive. F double prime means what? Means d2y dx squared. Okay, you learn in Maclaurin's F double prime. Okay? Yes? d2y dx squared is positive for x positive, is negative for x negative. Which means don't copy it, okay? Which means for x, you know generally from this one, the tendency is always increasing like that. Correct? F prime is positive, is always increase like that. Okay? You know 0, 0 is a stationary point. That means dy dx is 0. Actually, there's only one way to sketch this. It must be a smiley face here. It must be a set face, part of a set face here. Follow what I'm saying? Follow what I'm saying? Can? Like that. Is this a point of inflection? Yes, it's a point of inflection. Yes, it's a point of inflection. Yes, it's a stationary point of inflection. Because stationary means it is a stationary point. Point of inflection, for those who are interested, means the point where the curve changes curvature. It changes from a concave downwards to concave upwards. That is a point of inflection. A special point of inflection is where at this point of inflection it's also stationary. That means dy dx is 0. That is a stationary point of inflection. Can you think of typical equation? Yes, of course, y equals to x cubed. Or y equals to x5. Not x6. Okay? Can? Alright. Let's do some calculator work now. Come, take out your GC. Okay? Let's do some calculator work, okay? We are supposed to key in what is the function? X squared x minus 3. Okay, we all know how to sketch this. The idea now here is I want to sketch the gradient function of this. Okay, gradient function. How do we do it? Wait, let me do something first. Too many windows. Okay. Next, what is important now is we can actually sketch the gradient function by doing this. Okay, you go to y equals. You press alpha window, and then you press 3. What you are trying to tell the GC to do is, I want the GC to help me differentiate. Differentiate what? Differentiate this guy. You can retype this, or you can enter y1 directly. Alpha trace. Enter. You are telling the GC at every point I want to differentiate. I want to find the value of the dy dx, and then help me trace every single point. So let it be x. And then let us then differentiate the two. One is a thicker line, one is a thinner line. Like that. Alright, maybe what we can do is from -5 onwards. Like that, not very clear. Never mind. Let us do something. Where is my... Wait, I'm going to do something. Okay, maybe what we can do is you look at your own sketch and we can do this a few deductions. Let's look here. Let's look here. Let's look here. This is the deduced f prime x graph. This is the original C1. Can we do a few deductions? Okay. This is a bigger one. Fx, or look up. There's not much copying. Let's look up. If fx is increasing, this portion, here. Can I have attention? The blue one, let's orientate ourselves. The blue one is the original graph. The red is the f prime x. Is it obvious to all of us for this entire portion where it is increasing, the red graph lies above the x-axis because dy dx is positive. Okay? For this entire portion that is increasing, again the red portion lies above the x-axis. Do you follow what I'm saying? For this entire section where it's decreasing, the red portion lies below the x-axis. Second observation, AB is a stationary point. Where is AB? If I have a stationary point at the blue portion, maybe I erase this one. This is a special point. This is another special point. If there is a stationary point here, at this point the red graph, which is a deduced f prime x graph, should take on the value 0 because dy dx is 0. Also here, dy dx is 0. Next, if it concave upwards for C1, that means concave upwards means smiley face, right? Smiley face like that, this whole section smiley face. Then your f this part is increasing. Okay, maybe I highlight this. This is hard. This is a bit harder. This portion is part of a smiley face. Correct? This portion is part of a smiley face. Therefore, this whole section is increasing. Where exactly is this point? Does this point start? I have no idea. There's no need to pinpoint exactly where. But in general, you know this part of a smiley face, this is part of a sad face. Somewhere below here, it should turn from decreasing to increasing. Do you follow what I'm saying? Yes? Okay. Never mind. Let's try and do this. Example 16. Okay? Do this together. Are you okay? Well, not okay already. Never mind. Not okay. Then we will continue next week. I started early. I will return you the time. Okay? Can? All okay? So we'll continue. Definitely continue next Monday. Please. Sorry? Is there a table? You need to copy, is it? Okay, copy this and you can go. Please bring your book 4 next Monday. Book 4. We will do chapter 13, not 12. Okay? We'll do chapter 13. Okay? Book 4. Please bring book 4. Chapter 13, arithmetic progression on Monday. Because we'll definitely finish this on next Monday. Okay? Please bring along book 4. Math Rep, if you have not collected book 4, please collect it and bring it along. Everybody bring it along next Monday. Okay? Chapter 13. 1-3. Okay?